This is the Databricks Data Engineer podcast. Nobody on your team ever decided to build a data swamp. There was no meeting, no design doc, no ticket titled, "Let's make this unqueryable by Q3." And yet, here you are, 6 months later, staring at a table that takes 4 minutes to return a row count. By the end of this episode, you'll be able to name the 4 ways a clean lake house silts up into a swamp. Point at the one eating your own catalog right now, and know the senior counter move for each. Let's get into it. Because a swamp is not a decision. It's the sum of a few dozen reasonable shortcuts that compound into something nobody would have signed off on all at once. Picture a table you built right. Well-partitioned, documented, fast. Now run the tape forward 6 months. Week 3, you point a streaming job at it, no target file size, because the docs example didn't set one either. Week 7, a teammate is blocked, and the fast unblock is to flip on merge schema and let their new column just land. Week 12, someone spins up a copy, calls it the same name with temp on the end, and leaves the company in March. The temp table does not leave. And that vacuum job? Somebody turned it off during an incident and never turned it back on. None of those is a crime. Everyone, on its own day, was the reasonable call. That's the trap. The swamp doesn't form by event. It forms by gradient. I used to think swamps were a discipline problem. Sloppy engineers, careless writes. I was wrong. The swamp is mostly built by careful people making fast, locally correct calls under pressure. Which is worse news because you can't fix it by telling people to try harder. They were already trying. So forget memorizing a long list of bad habits. There are really only 4 ways a delta table silts up. 4 kinds of silt. And almost every team has one dominant one, not all 4. As I walk through them, figure out which silt is filling up your worst table. Let me start with the one you can literally feel. The first silt is file silt. Picture the riverbed. Every write drops a little sediment. One write, a grain of sand. You'd never notice it. But a streaming job, writing tiny files every 30 seconds, no target file size, no compaction. That's a dredger running day and night, dumping silt into the channel. And here's what that feels like. Your query isn't slow because the data is big. It's slow because to read 3 gigabytes of actual data, Spark has to open and list and crack open the header of 40,000 tiny files first. The work isn't in the reading, it's in the rummaging. This is the small files problem, the single most common silt on the planet. Now you're probably thinking, I turned on auto-compaction, so I'm fine. Maybe. But auto-compaction kicks in after the mess already exists, and it won't save a streaming write that never set a target file size to begin with. So what does the senior do? 2 moves. First, they set a target file size and run optimize on a cadence that matches how fast the table actually churns, not as a panic when somebody complains. Second, and this is the one that separates levels, they treat file size as a design decision at write time, not a cleanup job at read time. They decide how much sediment the river carries, instead of dredging the channel after it silts. File silt you can feel. The next one you can't feel at all, which is exactly why it's worse. The second silt is history silt. Every delta table keeps a history. Every version, the files behind it, all sitting there so you can time travel back. A genuinely beautiful feature, right up until it isn't. Delta's default is to keep the files behind deleted versions around for 7 days, so Vacuum has something to clean up. But if nobody ever runs Vacuum, those files never leave. Ever. You're not keeping 7 days of history, you're keeping all of it. Forever. Every version of every row that table has ever held. Now picture the conversation. Your manager slacks you. Why did our storage bill go up 40% this quarter? We didn't add any new pipelines. And you go, look, and the answer is one table that nobody has vacuumed since the incident. It's not new data, it's old ghosts. And you won't catch this in a query. The table reads fine. time travel works. Everything looks healthy right up until the bill lands. Invisible until it's expensive. Now I can hear the objection. So you're telling me to throw away my history. What if I need to roll back? No, I'm telling you to keep a decided amount. 14 days because you chose 14 days as a feature. 400 days because you never thought about it is a bill. The counter move is almost boring. Have a retention policy and enforce it. Decide how far back you genuinely need to travel, set the retention to match, and make sure vacuum runs. The skill isn't knowing the command. Everybody knows the command. The skill is deciding, on purpose, how much past this table drags around. Now, some of you are thinking, on our managed tables, predictive optimization runs vacuum for me. Not my problem anymore. On those, fair enough, that one's mostly handled. But notice the word managed. The tables that silt up are usually the ones predictive optimization doesn't touch. The external tables, the old Hive ones, the schema where someone quietly turned the optimization off and nobody turned it back on. And even where it does run, it only cleans up to the retention window you set. So the robot sweeps the floor. You still decide where the walls are. That's the silt you feel and the silt you pay for. The next one makes the table impossible to trust. The third silt is schema silt. This one starts with your most generous instinct. A teammate is blocked. They've got a new field, they need it now, and the fast unblock is merge schema. Flip it on, their column shows up, everybody's happy. You did a nice thing. Now do that nice thing 40 times over 6 months and look at what you've got. 3 fields that all mean customer status, with slightly different spellings. Everything nullable, because nothing was ever a contract. Then somebody new joins, opens this table, and asks the question that should terrify you. Which of these columns is the real one? And nobody knows. The schema became a junk drawer. And no, this isn't schema evolution is bad. It's a power tool, and you've been using it as a doorstop. Merge schema is for when the schema genuinely needs to evolve and you've thought about it, not a way to skip the conversation about whether this column should exist. The senior move is to treat the schema as an interface, not a landfill. New column means a tiny decision, not a reflex. Required things are actually required. And this is the one nobody does. Columns get retired. A field that's been null for 3 months. A senior finds out if anyone reads it. And if nobody does, they kill it. So that's the silt you can't trust. The last one doesn't even live in the table. It lives in your org chart. The fourth silt is ownership silt. The first 3 are technical, and technical you can fix on a Tuesday afternoon. This one is human, and human is the silt that buries you. You go looking for who owns a table that's misbehaving. No owner field, no doc. The person who created it left a year ago. There are 4 tables with nearly the same name, and you cannot tell which one is wired into the executive dashboard and which is a dead experiment. So what do? You touch none of them. You leave all 4 burning storage, because deleting the live one by accident is a very bad afternoon in front of your VP. Sound familiar? Nobody can clean up a swamp where nobody knows what's load-bearing. The not knowing is the silt, and it's why swamps never shrink on their own. Every orphan table is a thing future you is too scared to touch. And scared of touching is how a table goes from slow to permanent. The senior counter move here is the cheapest in the whole episode. Ownership is a default, not a favor. Every table has an owner and one honest line about what reads from it. Temp tables get an expiration the day they're born, not a prayer that someone remembers them. And the real senior tell? They make the catalog legible enough that a new hire can delete the right thing without a meeting. A lake house where nobody's allowed to delete anything isn't safe. It's just a swamp with good manners. So that's the 4. File silt, the tiny writes you feel in your query times. History silt, the versions you never vacuum that you feel in the bill. Schema silt, the junk drawer you feel when you can't trust a column. And ownership silt, the orphan tables you feel as fear. One caveat, because there's a version of this advice that becomes its own disease. If a table is genuinely throwaway, a scratch table for one afternoon, a staging table rebuilt every run, you don't need a retention policy and a schema contract for it. Over-governing a disposable table is just a different swamp, one made of process instead of files. The silt rules are for tables somebody depends on, and the senior skill is knowing which tables those are. That's what I've got for you today, so go look at your worst table. I'd bet it doesn't have all 4 silts. It has one dominant one. The question to carry isn't how did it get this bad, which leads nowhere. It's which silt is this? Because the moment you name it, this is just how tables get over time, turns into this is history silt, and the reversal is a retention policy I can write this week. A swamp feels like fate. A named silt is a task. The engineers who keep their lake house fast aren't more careful than you. They just learn to see the silt while it's still a grain of sand. If this one landed, send it to the engineer who's been quietly afraid of that one table nobody owns. They'll know which one. See you next time.